Welcome to Deep Dive. Today we're tackling a topic that's just buzzing everywhere, AI. You know that feeling, right? You're trying to grasp something new, and bam, you're hit with all this jargon. Super confusing. Yeah, we've all been there. So our mission today is simple. Cut through that noise. Simplify it. We've got some great source material, especially from the PM shelf, an article called 5 AI Jargons Every Product Manager Should Know. So if you're PM, maybe a developer, or honestly just curious about what's behind all this tech, well, this deep dive is for you. We're going to unpack 5 really crucial AI terms, foundational stuff you need to know to understand where things are going. Okay, let's dig in. To really start, we need to talk about the one grabbing all the headlines. Generative AI. What exactly is it? And how is it, different from the AI we were maybe used to?
Well, it's fascinating, isn't it, how quickly AI is just weaving into everything. And understanding these terms, it's not just about sounding smart in meetings, not at all. It's really about being able to actually envision new product ideas, talk sense with your engineering team, and really get the implications for users
Yeah.
for your strategy. So yeah, this deep dive, it's kind of a shortcut to getting properly informed, moving beyond just hearing the buzzwords. Okay, so generative AI. Think of it like this. It's a branch of AI that's focused on creating new stuff, new content. It's not just analyzing data that already exists.
Ah, okay, so different from, say, an AI that tells you if a picture is a cat or a dog.
Exactly. That's
Yeah.
classification or prediction, like forecasting the weather. That's traditional AI, more or less.
Hmm.
Generative models, they actually synthesize original outputs from scratch. They learn these deep patterns from just massive amounts of data and then use that learning to produce, well, new text, images, even video, audio code, lots of things. This is the magic behind those chatbots that sound so human, or tools that draft emails for you, or even AI design assistants. It's really about bringing something genuinely new into existence.
Huh. So it's less like an analyst summarizing reports
hmm
and more like a creative partner who can actually draft the report, design the presentation slides, suggest marketing copy, all based on context.
Precisely. It's that shift from just analyzing what was to actively creating what could be. That's why it's opening up totally new product areas, not just making old ones a bit better. It's inventive, not just reactive.
That's a huge shift, analysis to creation. Wow. Okay, so when we talk about these creative tools, one name pops up constantly.
hmm
GPT, ChatGPT, obviously, but it's under the hood of so many other things now. What do those letters actually stand for? And, why does it matter for someone trying to build stuff with it?
Yeah, breaking down GPT really helps. It clarifies what it can do and why it's such a big deal. So the G, that's generative, we just covered that. It creates new content. Novelty engine, basically.
Got it. Generative creation.
Then P is for pre-trained. And this is key. It means the model went through this enormous initial training phase on just vast internet scale data sets, like reading a huge chunk of the internet.
Whoa.
Yeah. This huge general training lets it learn language inside out, grammar, facts, reasoning, even different writing styles, all before you apply it to your specific problem. It's why they seem so knowledgeable right away. They have this massive foundation.
Okay. Pre-trained, like a massive general education.
Exactly. And then the T, that's transformer. This is the really crucial bit, the underlying technology. It's a specific type of neural network architecture. And this is the breakthrough that lets these models understand context, nuance, relationships, and language way better than older models.
The architecture.
Yes. It's what makes GPT so powerful for tasks that need, understanding long conversations or subtle meanings. So for a product manager, understanding GPT means you know you're using a system that's already packed with knowledge, can create new things, and understands language deeply because of this transformer architecture.
Right. That T for transformer sounds like where the real secret sauce is, the engine, like you said. It feels like this architecture just changed the game. What was the big problem it solved? Why was it such a breakthrough compared to what came before?
Right. So older models, you might have heard of RNNs or LSTMs,
Oh.
recurrent neural networks, long short-term memory.
Vaguely, yeah.
They processed information sequentially, like one word after another. And they really struggled with what's called long-range dependencies.
Hmm.
Basically, they had trouble remembering context from, say, a few sentences or paragraphs back.
Like reading a long document and forgetting the beginning.
Exactly. Made it hard to grasp the full picture in complex texts or conversations. Transformers. They fundamentally cracked this. They can look at the entire passage of text at once, essentially, and keep track of context across the whole thing. That's why they're so good at stuff like summarizing long articles, translating complex sentences accurately, or having a natural back and forth conversation.
Okay, so how do they do that? Keep track of everything.
A core idea inside them is attention. You can sort of think of it like the model having a super smart spotlight. It can instantly shine that spotlight on the most relevant parts of the input text for whatever task it's doing, no matter how far apart those parts are.
Spotlight. Okay.
So, take a sentence like, the cat sat on the mat because it was tired. The model needs to know if it refers to the cat or the mat. Attention helps it weigh cat much more heavily because, well, mats don't usually get tired. It connects tired back to cat.
I see. It focuses on the relevant connections.
Precisely. And then there's self-attention, which is even more powerful. It lets every single word in the input basically look at every other word in that same input
Yeah.
to figure out how they all relate to each other and which connections are most important. That's how it builds that rich, coherent understanding of context, making sure tired links to cat, even across really long passages. It's like it's actively reading and connecting all the dots simultaneously, seeing the whole forest, not just individual trees one by one.
That makes so much sense. It's actively building the meaning. So for something like, say, a customer support bot, using a transformer,
Yeah.
how does that feel different for the user compared to older bots? Does this mean they're, like, perfect now, or are there still limitations?
That's a great point. For that support bot, it means it can actually follow a conversation. It remembers what you said 3 messages ago.
Less repetition then.
Way less frustration. It feels more like talking to someone who's actually listening. But perfect. Oh, definitely not. Transformers are amazing with context, but their limits often come from the data they were trained on. If that data had biases, the model will likely reflect those biases.
Right. Garbage in, garbage out, kind of.
To some extent, yes. And if the training data is old, its knowledge is stuck in the past. It won't know about recent events unless it's updated or combined with other techniques.
Okay, so how does it work, like mechanically? Input to output.
At a high level, it takes your input text, chops it up into smaller pieces called tokens. Think word fragments, punctuation.
Tokens, okay.
Then it converts those tokens into numbers vectors called embeddings. That's how the AI understands them mathematically. These embeddings go into an encoder, which sort of reads and digests your input, building a rich understanding. Then a decoder takes that understanding and generates the output, the answer, the translation, the summary, whatever, step by step.
That sounds incredibly complex, especially the learning patterns bit. How does the training actually happen? How do they learn?
Training is. No. It's intense. It involves feeding the model just billions and billions of sentences. And for each sentence, it tries to predict what the next word should be.
Just predicting the next word?
Sounds simple, but doing it billions of times forces it to learn grammar, facts, context, style. When it gets a word wrong, it adjusts tiny internal parameters, its weights or knobs to try and get it right next time. It's this massive, iterative process of predict correct, predict correct.
And that takes serious horsepower, right?
Oh, yeah. Huge amounts of data, massive computing power. Think specialized chips like GPUs or TPUs running for weeks, sometimes months for the really big models. Over time, it captures all this linguistic knowledge. But again, not perfectly. It's learning statistical patterns, not true understanding in the human sense.
So as a product manager, I'm probably not doing that massive training myself.
Almost certainly not from scratch. It's incredibly expensive and resource-intensive. You'll usually start with one of these powerful pre-trained models from companies like OpenAI, Google, Anthropic, Cohere.
Okay, so you start with this powerful general brain. But what if my product needs it to be really good at something super specific, like medical terminology or legal documents? A general model might mess that up, right?
Exactly. And that's where fine-tuning becomes essential. Fine-tuning is basically taking that general pre-trained model and giving it further specialized training on your specific data.
Like a postgraduate degree for the AI.
That's a great analogy.
Yeah.
An off-the-shelf model, even a powerful one like GPT-4, might not know the nuances of your industry or your company's specific knowledge base. So you feed it thousands, maybe tens of thousands of examples relevant to your domain medical records, legal contracts, your product support chat logs.
Yep.
The model then adjusts its internal knobs again, but this time focusing on mastering that specific type of information and task. The result: a model that performs much, much better on your specific use case without needing to build everything from the ground up.
So you could fine-tune a GPT model on medical texts to make it a better doctor's assistant.
Precisely. Rather than relying on a generic chatbot that might misinterpret complex medical terms or concepts. For a PM, understanding transformers and fine-tuning means knowing you can get both broad capability and specialized expertise. You leverage the giant pre-trained model, then efficiently tailor it.
That's powerful. But You mentioned limitations. One big concern people have with these LLMs, even fine-tuned ones, is hallucination. When they just
Or
make stuff up
yeah.
or give answers that sound plausible but are totally wrong or outdated. How do we deal with that?
Hmm.
Especially in products where being wrong is a big problem.
Yeah, hallucinations are a major challenge. And that brings us directly to our next term, retrieval augmented generation, or RAG. RAG is a really clever approach. It directly tackles hallucinations by combining information retrieval like a search engine with the generation capabilities of the LLM.
Okay, retrieval plus generation. How does that work?
So the core problem is that an LLM mainly relies on the information it memorized during training, which, as we said, can be outdated or incomplete. It might just guess based on patterns. Well, RAG changes that. Before generating an answer, the system first performs retrieval. It searches an external, up-to-date knowledge source, maybe your company's internal wiki, product manuals, a database of recent news, whatever you provide.
So it looks things up first.
Exactly. Think of it like instead of a student answering an exam purely from memory, they quickly consult their official textbook or notes first. This retrieval step finds relevant, current, and hopefully accurate information related to the user's query.
Okay, that makes sense. Find the facts first.
Then comes the generation part. The LLM takes the information it just retrieved and uses its language skills to synthesize that information into a nice, fluent, helpful answer for the user. So instead of the retrieval just dumping raw text like policy 3.1a, refund window 14 days, the RR system generates something like, yes, you can get a refund, just make sure to request it within 14 days of your purchase. You can start the process here.
So it grounds the answer in real retrieved data, but still makes it sound natural and helpful.
That's the beauty of it. It combines the LLM's fluency with the reliability of external verified knowledge.
That sounds incredibly practical. Almost like one of the safest ways to use LLMs in sensitive applications.
It's definitely becoming a go-to strategy for exactly that reason. RAG significantly cuts down on hallucinations because the answers are based on actual data you provide, not just the model's internal, potentially flawed memory. It keeps the AI's knowledge current without constant retraining because you just update the external knowledge base.
Right.
And it lets you integrate the AI directly with your own internal information, FAQs, technical docs, customer data, whatever. It's this great balance. Accuracy from retrieval, usability from generation.
Okay, but surely RAG isn't magic either. Does it create new challenges? Like, what if that external knowledge base it's retrieving from is messy or out of date itself?
That is the key challenge with RAG, you're right. The quality of the retrieved information directly impacts the quality of the final answer. So maintaining a clean, well-organized, up-to-date knowledge base for the retrieval step becomes absolutely critical. Data governance suddenly becomes super important for your AI's performance.
So you need good knowledge management hygiene.
Exactly. But for product managers, the takeaway is huge. RGG gives you a powerful mechanism to build AI features that are not just fluent, but demonstrably more accurate, trustworthy, and current. It's a strategic tool for safer AI deployment.
Okay, that's super helpful. We've talked about building them, training them, making them more accurate with RG. But how do you actually know if your AI feature is any good? Once it's built, how do you measure its performance? That sounds tricky. Is that where evils come in?
Yes, exactly. Evals or evaluations are fundamental. And you're right, evaluating AI is much more complex than testing traditional software. With traditional software, it's often pretty binary, right? The button either works or doesn't. The calculation is right or it's wrong.
Yeah, mostly.
AI, especially generative AI, is way more nuanced. Think about that support chatbot again. Is the answer just factually correct? Or do we also need to ask, was the tone right? Was it actually helpful in solving the user's problem? Did it sound like our brand? Was it polite?
Right, there's so many shades of good.
Precisely. So evals are the processes and metrics product teams use to assess all these different dimensions. They help you decide, is this AI feature ready for prime time? Does it need more fine-tuning? Do we need to put guardrails in place to stop it saying weird things?
So what kind of things are you measuring in an eval?
It varies, but common metrics include accuracy, naturally, did it get the facts right? Relevance, was the answer actually related and useful to the user's specific question? Consistency or robustness, does it give similar, stable answers if asked the same thing multiple times or slightly different ways? Then there's helpfulness. This is crucial. Did the output actually help the user achieve their goal? And increasingly important, bias, does the model avoid unfair, prejudiced, or skewed responses based on demographics or other factors? And safety, does it refuse to generate harmful, inappropriate, or toxic content?
Wow, that's a lot more than just correctness.
It really is. It's a holistic look at the AI's behavior and its real-world impact. For PMs, getting good at evils is key to shipping AI features that are genuinely valuable and responsible, not just technically functional. It's an ongoing process, too, not a one-off check.
So much more about the overall quality and impact, the fairness, the whole experience. It definitely sounds like a continuous loop of building, measuring, refining. Okay, wow. We have covered a ton of ground today. This has been incredibly clarifying. From generative AI's creative power to the transformer architecture making sense of language, how they learn through training and fine-tuning, then our adjuting accuracy, and finally, the complex world of evils to measure quality. We really unpacked some core jargon.
We did. And it brings up a really interesting point, I think, for everyone listening. Given how complex evaluating AI is going beyond just right or wrong, how do you define success? For an AI system you might build one day, or maybe just one you use every day, as these tools get deeper into our lives, thinking critically about their performance, their fairness, their safety, that becomes crucial for all of us, doesn't it? It really shapes our experience.
Absolutely. That's a great question to ponder. Understanding these terms, it really isn't just about the vocabulary, is it? It's about getting a much deeper feel for the innovation happening, but also the very real challenges and, of course, the incredible potential. And hey, if you are keen to dive even deeper, see more real-world examples, sources like the AI Product Manager's Handbook by Irene Bratzias or AI for Product Managers by Chavi Sharma are fantastic next steps. They really show these principles in action. Well, thanks so much for walking us through all that today. And thanks to all of you for diving deep with us. Until next time, keep learning, keep asking questions, and keep exploring.